Here's how it works in theory. There are two components to risk management. You have the current risk of the analytical process, and this is what we've managed for years and years and years. We do key staff training, we do method validation, we do daily QC, proficiency testing, we do inspections, we do accreditation, and then you have the potential risk of the QC process. If all of this fails, if the analytical process fails, you rely on the QC process to prevent harm to patients. This answers the question, is my risk acceptable today? This answers the question, will my risk still be acceptable if the method fails tomorrow? Here's what happens. There's an initiating cause, something goes wrong, the system fails, it generates an incorrect result. The question becomes, will that result be reported or not? These are potential failure modes that are listed in EP23. Now, you could start by saying, can I identify every single one of these failure modes without using stable sample QC? If you can, then the rest of this lecture has nothing to offer you, because this is dealing with that last line of defense that is the statistical QC sample or the stable QC sample that you use to mirror your patient samples and to make sure your patients are working. So regardless of what you've done to prevent, regardless of the lists and checklists, if a final error gets through, will that QC sample detect it? Failure is, in the broadest sense, a system that doesn't meet the user's expectations. In the lab sense, it means it is unable to perform its intended functions satisfactorily or within specified performance limits. Performance limits have been part of theory forever. An incorrect result is a result that doesn't meet the requirements for its intended medical use. In the case of quantitative test procedures, a result with a failure of measurement that exceeds a limit based on medical utility. It is all about preventing patients from medical harm. If you have a verified effective risk management process, it will put a block up here and stop that incorrect result being reported. Failures in the testing system impact all patients tested until the failure is corrected. We talk a lot about pre-analytical, analytical, and post-analytical failures. The big difference is that pre-analytical and post-analytical failures tend to affect one patient, a small batch of patients. But when something goes wrong with the analytical process, it churns out potentially thousands of unacceptable results that can lead to misdiagnosis, that can lead to hazardous medical actions, that can lead to patients being harmed. What can you do? Well, for all tests that create numerical results and rely on stable sample QC, when the lab director sets the medical goal and acceptable risk level, the risk management process can be evaluated, improved, and essentially automated if you have those numbers. So remember the 80-20 rule. I guessed at this, but I think about 80% of the tests we perform create numerical results, rely on stable sample QC to detect changes in accuracy or precision that could produce medically unreliable results that harm patients. Those are the ones we're talking about today.